we're going to go through more specialized staining techniques than we use. The most widely used probably it's the gram staining, and I bet if you hear anything about bacteria, you might have heard the terms gram positive or gram negative. Now, gram staining was developed in 1884 by Hans Christian Gram, and it is very useful to differentiate between two types of bacteria, a gram positive and a gram negative. Now, this is really useful because every bacteria, or almost every bacteria, fall either between any of these two categories. And they have a morphological and biological significance. It's extremely useful, and it helps us differentiate based on a biological component, which is the cell wall composition. Now, so I can promise to you, I will ask at some point the difference between a gram positive and a gram negative bacteria. The most common answer that I get to that is gram positive bacteria purple, gram negative bacteria pink. Well, it's not correct. We make gram positive bacteria purple, we make gram positive bacteria pink by doing gram staining. But reality is that the difference lies within the cell wall. For gram positive bacteria, we have a thick cell wall of peptidoglycan with fewer lipids, and for gram negative bacteria, we have a thin cell wall of peptidoglycan and an outer membrane of polysaccharides, which is high on lipids. Now, that's basically the difference, but it also has clinical implications such as resistance to antibiotics, for example. Most antibiotics attack the cell wall or cell membrane, so gram-negative bacteria tend to be more resistant, whether gram-positive are more susceptible to antibiotics. But then if we go to antiseptics and just plain old detergents, so gram-negative bacteria tend to be more susceptible to alcohol-based antiseptics and so on. So it's not only a difference in the staining, but there's also a meaningful difference in the biology of the bacteria itself by them being gram-positive or gram-negative. So this is a very gross, or a very, gross illustration on what the technique is. And this is what we call a differential stain. A differential stain uses two stains. So that's very important to do. Simple stain only uses one, a differential one uses two. What we call a primary stain and counter stain. And I will go over the procedure, but to let you know why this procedure works and how we can detect that difference in the cell wall using this. And what we do is we do a direct staining of crystal violet. So if we start with our bacteria and doing our smear, we will dye our bacteria, both the gram-positive and gram-negative, with crystal violet. Then we are going to add iodine. Iodine is a mordant, which it basically will help fix the crystal violet onto the bacterial cell wall. And now we are going to do a step that is called decolorization. That decolorization step is going to be done with 95% ethanol. It's 95% alcohol. That's how you have it labeled on your benchtop. Now, let me go back for a moment to this image right here for you to visualize what's happening at a micro level when we're doing that. So, okay, we stain with crystal violet. Crystal violet gets, so it's a positive stain, so it basically sticks to the cell wall of both gram-positive and gram-negative bacteria. Now we add iodine as the mordant, and that helped fix that. It helped fix that stain to the bacteria cell wall. And now we add alcohol. Now, alcohol is an organic solvent. And we have fats in the outside of gram-negative bacteria. So what happens is basically with that alcohol, we're washing away the stain and part of the cell wall, all of these phospholipid, polysaccharide and lipid membrane of gram-negative. And what happens with that decolorization is because of this fatty layer in the outside, they lose the stain when we decolorize quicker than gram-positive bacteria. And that's why we're able to differentiate using our gram stains. Remember that I told you that gram-negative bacteria were more susceptible to alcohol-based detergents, or they even can't grow in alcohol-based agars, for example. We'll see that later on. So we use this step to decolorize and take the crystal violet out of the gram-negative bacteria, and then we do a final step that is called counter-staining. Counter-staining will stain the bacteria that are not stained from crystal violet, and when we observe them under the microscope, then we will observe gram-positive bacteria as purple, gram-negative bacteria as pink. All right, and that's how we make gram-positive purple and gram-negative pink. All right. Now, the most critical step in this gram staining procedure is the decolorization. All right. In this case, we can over decolorize or we can under decolorize. Over decolorizations will result in false negatives, which it means basically that if we over decolorize, we can actually take some of that crystal violet out of gram-positive bacteria, and bacteria that are gram-positive will appear to be gram-negative. If we under decolorize, it means that we are not going to get rid of much of that crystal violet or that fatty layer of the gram-negative bacteria. And when we stain with safranin, that bacteria won't stain, making gram-negative bacteria appear to be gram-positive. It is explained in your lab how the decolorization step is done, but by using the alcohol on your droppers, once you are on that step, you're going to start putting drops of alcohol into your microscope slide. Let it run through your stain, and you'll see that at the beginning, you'll see blue or violet on your alcohol, and you're going to continue adding alcohol until you see the first drop of clear alcohol after your stain. And that's when we know we're in the optimal point of decolorization. All right. This right here is the procedure again, but using times. So times vary within a minute. So this should be a very quick procedure. So crystal violet goes through 60 seconds. We rinse that crystal violet because our bacteria have been hit fixed. That's very important. Grams iodine, 60 seconds. Let it fix that dye into the cell wall. Then decolorization, drop by drop, until we see clear alcohol. And then we do safranin by 30 seconds. We rinse, and we can observe under the microscope. This is a more detailed procedure, and I will leave this procedure on the PowerPoint, although follow the procedure on your lab manual, that's better. There's one modification that I want to clear out from your lab manual, and that's the following. So in your lab manual, it asks you to do a smear. So that's for exercise 6. It will ask you to do a smear of E. coli in one side of your microscope slide and a smear of Micrococcus luteus in one side of your slide. Now what I would like you to do is to produce an image that look a little bit more like the photograph that we see right here, where you can see both gram-positive and gram-negative bacteria together. So what we're going to do is we are going to make an E. coli smear a micrococcus luteus smear, and then we are going to mix them together. So in the intersection of those smears, that's the field of view that we're looking